text to speech. After performing text to speech, we'll get a response. After getting a response, we'll go ahead and store that detail in the database. Um, Again, database is again a local call or network call, could be anything. Could be a network call, could be a local call. But either way, it has to wait till the database sends a response after sending a request, and then it goes ahead and provides the response, which is audio, back to the user. So this is the process we are performing. In order to perform this process, in order to perform this simple operation, here's what we need to do. In our case, in our simple understanding, this particular time where it has to wait for a response from this web page, it might take 2 seconds, 3 seconds, 4 seconds. This where it needs to connect to a database, it might take 1 or 2 seconds or so on. These times where our thread is waiting, it can then tell the CPU, hey, I'm waiting. You do some other tasks, or this particular thread itself can do another operation and then get back by the time you get the response. So it continues to work. This whole idea is async. So what gets to happen is that whenever we are dealing with two type of tasks, either network bound or input output bound operation, not CPU, only network and input output bound operation. This is an IO operation. This is a network operation. Whenever these things happen, we get to use async to make sure that that particular time would be saved, and that thread, whatever is running it, will perform other tasks which will make your application faster. For example, if there's another person who's using this application and they're doing some other task, this can go help with other tasks and come back in simple and short words. This is what helps us. This is why async or asynchronous programming is a very powerful way to make sure that you can handle a lot of things together. That's one thing that we need to know. Now, let's start with this. In order to perform async, the simple idea is that your system or your program, whenever it is performing input output or network requests, instead of waiting them to finish, your program will perform other tasks which other users are waiting for and then get back to continue your task. That's it. To perform this or to use this, we use a particular package that is available within Python that is called async IO. Let's start with this. Right, so async IO is the library that we use within Python, which helps us write asynchronous code. The whole idea is any code that you write which needs to perform async operation, it needs to run within this framework called async IO, without which you cannot perform it. That's the whole idea. So to run or to implement async, we have to use async IO. Now, once we use async IO, we can start async operations. The idea is simple. We use await and async as two keywords. That's it. Any function, any function which is performing an input output or network operation, that function will be written with an async keyword, indicating that function will perform async operation. And whenever you're performing input output or network bound operation, you will use await keyword to make sure that it will perform other operation or other operations meanwhile. That is exactly what we have within this. I hope this simple idea gives, or this basic logic gives a simple idea of, let's say, what async and await is. And I'm so sorry, I'm getting a lot of noise. Yeah. So with this, we can begin performing async operations, as simple as that. Now, let's start with our first async operation. Anything you want to perform async operation in. Let's create a new file, async.py. Anything in which you want to perform async operation, you need to import async IO. And we have learned this. If name is equal to main, we just write async io.run of any function you want. Now, here's what I'm trying to say. Any function that has IO input, output, or network bound operation, run it in async IO. That's it. You have to run it in async IO specifically. Now, in this case, once you run it in async IO, the next step for you is to run that function, is to go to that function and run it. Let's go to that particular function and then perform something. So just remember, any function that has IO or network bound operation, you have to run it with async. The whole idea is your entire program should run in async. That's it. Whatever you do, whatever is the first function you run in your application, run it as an async IO run coroutine. When you run it as an async IO coroutine, it's going to perform this or it's going to execute this function with async. And that means you can make the best use of your program. So that function that we have, fun, before writing it, you have to use async keyword. When you perform async io.run, please remember every function should be written with async. Now, for our understanding, I'll just do this. Or let's not write this. Let's create a simple function as it is, which does not implement it. Then I'll write a function that does implement it. All right. So let's go ahead and write perform network call. So let's call this as app. This is our main application. In our main application, we will call perform network call. I'll tell you why I'm writing multiple calls, which is calling another function internally, so that we understand something better. Here, generally, if I want to perform some requests or some network call, I would import requests. And once we import requests, we just use requests.get of some URL. We'll just use, in our case, the dummy JSON URL that we have. So we have dummy JSON slash cards, and that's pretty much it. This is the basic idea of a function. This does not help us with async though, just for our reference. It helps in no way whatsoever. In order to make it async, here's what you need to do. This is the function that is making a network call. Any function that is making a network call should have await keyword with it, which means wait till you get the output. And any function that is having await should have async behind it. That's all. This is the basic rule that we follow in short. Any function that makes a network call or any function in which you're making a network call will always have to be written with async as a prefix. And now comes a question. What about the function that is calling this function? Because take a look at this. We are running app as async. Once you run app as async, app is then calling perform network call. So perform network call is async because it has a network call within it. for which we are writing await. So in short, network call await, the function that has network call async. And this async should follow through till here, which means this function is called here. That means this function should also be async. And this function is called here, so it is fine. So all the functions, if it is 10 functions deep that you're making a call, all the functions that call until here must always be async. This is how it works. So I hope this so far makes sense. Please just take a look at it for a few seconds, walk through it if you'd like, and please let me know if there are any queries whatsoever. I will um, help you through to make sure that we walk through the same and answer any queries in async till now. Once you have cleared these queries, we can move ahead to the next part of it. Right, so no queries. In that case, let's go ahead and write this. So only thing I need to do is, since we are starting our application with async IO, the first function that is called is async. The function that it calls is also async. And the requests will also be async. But here's the problem. Requests is a very old package. It does not support async by default. If you want async to be supported, instead of requests, you need to use HTTPX. So please remember, apart from requests, there's another package called HTTPX. This is not directly available, so you'll need to import it. Just pip install HTTPX and it's done. And don't worry, HTTPX is very similar to requests. It is very, very similar. You just have to use, instead of requests dot get, you need to use a HTTPX client dot get. That's all. And this client that we create in HTTPX should be an async client because we are only async operations can work with them. So I need to write HTTPX dot async client. So not byte string, async client. So I need to create an object of HTTPX async client, and then I need to use that client to get it, and then I need to close this client. So remember, if you remember, anytime we have to use a logic where we have to open a connection and close a connection. To avoid closing connection, we use with. If you remember with open of file comma read as file, we perform some operation, but we never do file dot close because when you use with, you don't ever have to close connection. The moment you exit this indentation, that connection is by default closed. So the same thing is what we're going to do in our case. To create a HTTPX async client and close it without having to use close function by ourselves, we use with HTTPX dot async client as client, we perform this operation. So once this operation is performed and you get out of the indentation, this HTTPX async client is automatically closed then and there. That is all that we need to know. So let's go ahead and implement exactly that and see how it works out. Right. So let's start here with HTTPX dot async client as client. Again, I understand that these are new. The moment we start working into this, it's all new, but just note a few important things that whenever we start to work on things like async and things like multi-threading, these, especially when you want to perform a lot of operations on your PC, it'll help to make sure that you're using the highest capacity of your CPU possible to make sure all your operations are much faster. And this will help a lot when you want to perform large or want to create large applications just in case. Now, with this idea, let's go ahead and go to the next part of this. Let's take response equals, in our case, we just need to make a call to this. That's pretty much all it is. So response is equal to client.get. Again, same as what we did, exactly same as what we did. We use get for this URL, and that's it. We're done. But there's one catch here. Remember when we said we need to use async for every function and await for every network or in, input output blocks, IO blocks or IO calls. This is a network call. Since this is a network call, you're going to use await. And whenever you use with, just like async, whenever you're using with, because they are also a sort of function which perform operations, you'll use async there as well. So just remember, once you perform async io.run of your application, in your application, every function will be async. And when each function is async, you keep going ahead even till with. And wherever you perform network or IO operations, just write await before it. This is going to make your entire application async, which means until we get the response here, if your program can do anything else, any other process, it will do that. So let's just go to this particular directory and let's run async.py. Let's see. It says something was never awaited. Okay, let's see where we went wrong. It particularly says something was never awaited. Let's just observe this once. Oh yeah, I'm so sorry. We have to await here as well. In an async function, every function will be async, and wherever you're performing network call, it'll be awaiting. And whichever function it is that you're performing the network call, that also has to await. Now you can run it, it'll execute. We won't get to know it, but while it is waiting to get the response, it will perform some other operation. That's the whole purpose of it. This is how async works. Now, if you want your TTS application to be better, for example, you can go back to this TTS app. Okay, prior to that, let me just give you a few seconds to walk through this and I'll add a few comments so that we can understand this better. And followed by this, I'll go ahead and go to the next part of it. Right. So just remember, all async. Okay. We define a function as asynchronous by prefixing it with async. Similarly, we define function calls and network or IO bound calls with await. These two will pretty much help us perform this whole operation. So run this whole application with async IO. All functions will be async. All function calls and network calls will be await. That's it. If you do this, you've got your whole application done. And this is how it works. So please take a minute if you want to go through it. If there are any queries within it, please feel free to let me know. I will help answer the same. And then I'll just give you a small idea on how you can do this for our TTS application. However, I would like you to try it out, but I'll just give you an idea to work around it. Right. Now, there are multiple ways to do the same thing in Python, to be truly honest. Instead of HTTPX, you have another thing called AIO HTTP. Sorry for that. So instead of HTTPX, you have another package within Python called AIO HTTP, which will help you directly perform async operations with HTTP. So there are multiple ways to do the same thing. In async IO, what we did was HTTPX client, right? HTTPX.async client. Instead of that, you can use AIO HTTP. Please hold on. We can use AIO HTTP with AIO HTTP's client session as well. So just to point out, there are multiple ways to perform exact same operations within Python, just so we know. Right. With this, I'm just going to leave it at this. If you want to try out, it's the same thing. You run your function with async, and when you run your function with async, you again do the same operation. Start with a client as client with async, and they're also trying to get the web page as async as response and providing the response. Every little part they're adding a wait at the end. This response.text and response.text is what they're awaiting. So you can do it in multiple ways, but this is a simple way to do it. You don't have to complicate it with AI or HTTP. But if you want to look into it, if you want to learn it, if you want to work around it, this is a beautiful library to learn ahead in time. And since we are working on async, I just want to introduce you to one simple thing called Fast API. Fast API is another framework just like Flask that we have. The only difference is Fast API, unlike Flask, is async by default. So whether you use async or not, it's async by default. Um, so I don't know if they have specified that is the reason. So you can see here, HTTPX is the default one that they use, not HTTP. This makes it really, really fast because it's just made with all the packages that you have that is faster than the default packages. And it is async by default. I'm not sure why I'm not able to find it here. Okay, they have not specified it here. It's fine, but anyway, you can use async readily within this. You don't have to start your app as async app. Fast API application is by default async. Since it's by default async, every function can be written as async, and you can start performing await operation there. This is one advantage of Fast API. You can see it is similar. We used from Flask import Flask, here from Fast API import Fast API. Then we use app equals Flask. Here they use app equals Fast API, and the same thing. There is app.get. In our case, it was pretty much similar. When you start to work on app, we did it in controller. You can see app.route and add a URL. Here it's app.get or app.post, whatever you want, you change it here itself. So there are slight differences, but the rest of the thing is pretty much the same. So if you want to learn Fast API ahead because you already know Flask, it should be pretty easy to do that. Right, that's one thing. Let's move ahead from here. The next part of this that is quite amazing to learn after Fast API is, oh, sorry, after async is multi-threading. Now, the whole idea of multi-threading is, in order to understand this, we need to go back into how CPUs work. We know that whenever we look at CPUs, we observe and understand CPUs. We have CPUs like dual core and quad core CPUs and so on. These basically mean that your CPU is divided into four different parts, and each part can run one process at a time. That's the whole idea. So each little, let's say, core in a quad core means we have four cores. In a quad core CPU, each core can run one process. And Intel went another level ahead to say we can divide each core into multiple logical cores, which is called hyper-threading, where in each core, instead of running one process, you can run two processes. In other words, two threads at a time. So the whole idea is that you can run multiple threads simultaneously. One thread will run in one core, another thread will run in another core, and so on. And that is where multi-threading comes into existence. If you create a single threaded application, it will use only one core. If you create a multi-threaded application, it will use multiple cores of your CPU and utilize them simultaneously. You can do one operation in one core, another operation in another core. And I'll specify in detail why multi-threading is the norm nowadays, why every program that you see, almost every program that you see, is a multi-threaded program. I'll talk about that up next. But prior to that, we have reached that point of time again. So um, we have covered a lot. So let's take a small break, and let's join back by 2:45 p.m. Eastern time if it's fine with all of you. Let's take a few minutes of break. Please go relax, have a cup of coffee and chill, and we'll be back in 15 minutes and continue. Right? Thank you.